Okay, so you've sent over a really compelling set of materials. We've got your notes, these timelines mapping out AI progress, some really key publications, and Shunyu Yao's framework on the second half of AI research.
Yeah, quite a mix.
And the idea for this deep dive really is to try and synthesize these more academic viewpoints, to get to the heart of how the field itself sees AI's progress, how we measure it, and where things seem to be heading from that research angle.
Absolutely. And I think looking at these sources together, it really throws a spotlight on a central question for the field right now.
Which is,
Well, we've seen just incredible progress, right? Measured by how AI performs on all sorts of benchmarks.
definitely, the numbers are impressive.
But there's this ongoing discussion, and people like Xunyu Yao articulate it well, asking if these benchmark wins really mean AI is having a proportionally bigger impact in the real world, real utility.
Ah, okay, benchmark performance versus actual usefulness. That's the main tension we're exploring here.
That's the core tension. Yeah, it's what we really need to unpack today.
Got it. So let's start with this first half of AI research that Yao talks about. My reading is that the big push initially was all about developing the basic methods, the models themselves,
That's pretty much it. The research world was really focused on finding new ways to train models, new network designs.
like those big papers you flagged.
Exactly. Think about learning internal representations by error propagation. I mean, that gave us back propagation. Absolutely fundamental for deep learning.
Right. Couldn't do much without it.
Then you had AlexNet, which basically proved deep convolutional networks could crush complex vision tasks like ImageNet.
A huge moment.
And of course, attention is all you need. Introduce the transformer, and well, that's just everywhere now, isn't it? NLP, vision, you name it.
And you look at the citations for those papers, they're massive. They clearly had a huge influence. But it's interesting, you look at the benchmarks they used, the citations for the benchmark papers themselves are often, well, lower.
Yeah, that's a telling point.
So why was the focus so heavily on the methods back then, rather than maybe the tasks used to test them?
Well, I think there were a few reasons. For one, coming up with a genuinely new algorithm or a new architecture, that was often seen as the bigger intellectual leap. It took more theoretical insight, more complex engineering.
Right, harder, maybe more exciting?
Probably, yeah. And defining a benchmark, well, maybe that felt a bit more like just adapting a human task for AI. The real breakthrough was in the how do we make these things smarter?
So building better engines was the main game, and the test tracks were kind of secondary in terms of like academic kudos.
That's a good way to put it. Plus, think about something like the transformer. It turned out to be incredibly general, didn't it?
Yeah, it wasn't just for one specific thing.
Exactly. It worked for translation, text generation, even vision eventually. So a powerful new method could boost performance on lots of different benchmarks. Developing that just felt like a higher impact activity for researchers.
That makes a lot of sense. A general method lifts all boats, so to speak. Okay, so let's pivot to the second half. There's this idea now that RL finally works, and maybe more importantly, RL finally generalizes. What's going on there?
Right. The big thing here seems to be the emergence of this, well, surprisingly effective recipe for getting reinforcement learning to generalize.
A recipe.
Yeah, basically a combination of things that seems to work really well. Your notes in Yao's work lay it out, massive language pre-training, huge scale, both data and compute, and then building in the ability for the AI to explicitly reason alongside its actions.
Language pre-training, scale, reasoning. Sounds like the playbook for a lot of the big models we see now.
It absolutely is.
But why is that specific mix the key to generalization in RL?
Well, traditionally, RL research was super focused on the algorithm itself, right? The core learning process, the environments, any prior knowledge the agent had, those were often secondary.
Okay,
But then models like WebGPT, ChatGPT came along and showed something crucial, that huge amount of knowledge baked in during language pre-training, basically this deep statistical grasp of language and the world that can be the dominant factor in letting an agent handle new situations well.
so wait, the pre-trained knowledge might actually be more important for generalizing than the specific RL algorithm you use. That feels like a big shift in thinking.
It really is. Yao points this out as kind of a surprising reversal. For ages, RL folks tweaked algorithms, often in fairly simple environments, without really thinking about plugging in massive pre-training from, say, language.
Huh.
Now, it looks like strong language priors just make agents better at reasoning and acting across different situations. Sometimes it makes the choice of RL algorithm almost feel like just an implementation detail.
Wow. Okay. And this links into that idea of reasoning is augmented action. I found that fascinating. The cooking diagram you mentioned helped. Could you elaborate on the sort of academic thinking behind that?
Sure. The cooking example is a nice, concrete way to see a broader principle. The agent sees, okay, I'm out of salt. Instead of just randomly trying things, it reasons.
Right.
It thinks, okay, goal is seasoned food, need salt, don't have it, substitute. Soy sauce, where is it? Probably in the cabinet to the right. This reasoning often happening internally using language-like structures.
Learn from the pre-training.
Exactly. That reasoning then guides the physical action turn right. Yao's point, the theoretical significance, is that this reasoning, based on all that pre-trained knowledge, acts like a special kind of internal action. It drastically cuts down the possibilities for external actions, making the agent much more efficient and goal-oriented.
So it's not just reacting, it's using its internal world model, its language model, to simulate and plan before it acts. And the React paper that connects reasoning thoughts with actions builds on this too, right?
Precisely, you interleave thinking and acting. By adding these explicit reasoning steps, powered by that rich understanding from language pre-training, you give the agent a much more sophisticated way to deal with the world. It becomes less purely reactive, more deliberate, it can anticipate, plan, and hit its goals better across more tasks.
Okay, so this recipe seems really powerful for getting good performance in generalization. But this leads us right to the crunch, the saturation of benchmarks and this utility problem Yao talks about. If AI is getting so good on these tests, why isn't it, changing the world more dramatically yet?
Yeah, this is a huge point in the community right now. Huge point of concern, even. You look at that AI benchmark progress graph you included, the gains are real across the board, right? GSMAK, ANTS, GPA, even coding benchmarks like SWE bench.
Yeah, the lines go up steeply.
It really shows the current recipe works incredibly well for these kinds of tests. But as people like Jason Wei have visualized, just making benchmarks harder and harder might be hitting diminishing returns.
How so?
Well, the capabilities unlocked by the current recipe might just be good enough to solve the harder versions, too, without needing fundamentally new AI ideas.
Right, like we're acing the tests, but maybe the tests aren't quite capturing what matters most in the real world.
That's a good way to put it, and that's the utility problem. We have AIs beating world champions at games, acing grad-level exams, but has the global economy fundamentally shifted because of it? Yao argues maybe not as much as you'd expect given those benchmark results.
So the worry is our measuring sticks, our benchmarks, aren't quite measuring the kind of intelligence that drives real-world value creation.
Exactly, and that makes us question the assumptions baked into how we evaluate AI. Yao points out one big word, automatic evaluation. The AI gets input, does a task alone, gets a score.
Okay,
But think about how many real-world uses involve back and forth with people. Customer service, for instance, it's not just one answer, it's a conversation. That bench framework you shared tries to get at this, right? By simulating a user and having domain rules.
yeah, the bench airline example was really clear. The agent has to know the request, but also the airline's rules about basic economy tickets, cancellations within 24 hours. It's not just isolated task completion.
Exactly. It brings in domain knowledge, interaction over multiple turns that feels much closer to a real application than just, say, answering a single question correctly.
Definitely more grounded.
Another assumption Yao questions is the focus on IID, tasks independent and identically distributed.
Meaning each test is separate, unrelated.
Right, but in the real world, learning is often cumulative. A software engineer gets better by working on the same code base over time, learning its quirks.
Like the Google SW example you mentioned.
Yeah. Many benchmarks test AL on a series of one-off problems. They don't capture that long-term learning, remembering context, building on past experience. The IID assumption just doesn't reflect that sequential reality.
So if Yao's right that when intelligence is low, improving intelligence generally improves utility, maybe the current recipe is optimizing for benchmark smarts that don't fully map to utility driving smarts.
That's the heart of the utility problem. The recipe works brilliantly under the old evaluation assumptions. To get real-world utility boosts now, we might need a fundamental rethink of how we measure success. We need evaluations that capture interaction, context, cumulative learning, the messy stuff.
And Blockbench is one attempt at that kind of rethinking. Can you walk through its main parts again?
Sure. Looking at your notes, TeleChBench has a few key pieces. You've got the tools. These are the functions the agent can use, like get user details or book reservation.
Okay, the available actions.
Then there's the agent itself, the AI being tested. And its behavior is shaped by two main prompts. The domain policy, which is like the rule book, basic economy can't be changed. And the user instruction, the specific request, change flight JK9019.
Got it. Rules and the current goal.
And finally, there's the user, often simulated, who interacts with the agent.
So it's not just about having the tools, but using them correctly according to the rules and the user's ongoing conversation.
Precisely. Look at that airline example again. User wants to change the flight. Agent uses tools, sees its basic economy, booked recently, applies the policy, no changes, but it also knows the 24-hour cancellation rule and offers that instead.
Okay.
User agrees, agent cancels. It's simple, but it shows understanding intent, getting info, following rules, and having a short dialogue to find a solution within the constraints.
Yeah, that feels much richer, much more ecologically valid than a static test. It includes interaction, context, rules.
Exactly. And moving towards evaluations like that, evaluations that mimic real interactive settings, seems crucial if we want to really understand AI's potential for actual utility.
So let's go back to that AI benchmark progress craft. With this whole utility problem and evaluation critique in mind, how should we view those big score increases now?
Well, the progress is still real, still significant. Those big jumps on GSM-8K, math, GPA, and especially how fast SWE bench verified went from basically zero to what, nearly 80%?
Yeah, that one was dramatic.
It absolutely shows the current recipe language pre-training, scale, reasoning is incredibly effective for the kinds of problems those benchmarks test. It validates the recipe in a way.
Good.
But it also strengthens the argument that if these benchmarks aren't fully capturing real-world complexity, then just chasing higher scores on them might not automatically lead to the big societal impacts we're looking for. SWE Bench Verified tries to be more practical, which is interesting, but does Verified there really cover everything a real software engineer does, collaboration and all? Probably not entirely.
Like we've gotten really good at teaching for the test, but we need to be sure the test actually measures what we need for the real world job.
That's a great analogy, and it loops back to Yao's main point. The research community really needs to fundamentally rethink evaluation, not just harder benchmarks, but genuinely new ways to measure progress, ways that align better with complex, real-world goals, and how we want AI to actually help us.
The reasoning and augmented action idea, especially with the cooking example, feels like a really useful theoretical way to think about how these systems are getting better too. It's not just raw compute, it's using that learned knowledge to guide actions.
Definitely. Yao calling reasoning a strange kind of action. That's quite insightful, isn't it?
It is.
It emphasizes how this internal thinking, powered by language pre-training, massively boosts the agent's ability to handle complexity. Reasoning doesn't directly change the outside world, but it intelligently narrows down what the agent should try to do next based on everything it's learned.
So looking back at that list of foundational ML papers and benchmarks again, that balanced scale image, it really hits home the historical tilt towards methods, papers, backprop, AlexNet, Transformer. They just dominate in citations compared to even widely used benchmarks like ImageNet.
Yeah, the citation difference is stark. It perfectly shows the first half priorities. Develop the tools, validate them with the benchmarks. The balanced scale idea is arguing that now in the second half, we need to put more weight, more intellectual effort on the real problems and the how we measured better evaluations.
Right, bring things into equilibrium. And even glancing at the contents page from Sutton and Bardo's RL book, The Classic Text, it reminds you how much focus there traditionally was on the core algorithms, the tabular methods.
Then the foundations.
It puts into context how much things have evolved, recognizing the huge role of the environment, and especially these massive pre-trained priors.
Exactly. That foundational work was essential, laid the groundwork. But adding large language models has really broadened the picture of what makes RL work well and generalize, showing it's about much more than just the learning algorithm itself.
Okay, so wrapping this up for you, our listener, it really feels like AI research is at this fascinating turning point. We've built incredibly powerful tools, but now the big questions are shifting. It's less just about how to make AI smarter on the old metrics, and more about what real problems we should aim it at, and how we measure progress in ways that actually reflect real value and utility.
Precisely. That utility problem seems like the central challenge for this second half of AI research. Tackling it means we really have to innovate on evaluation, get critical, move beyond the old benchmarks, and build frameworks that are more realistic, more interactive, more human-centered.
It definitely makes you think, doesn't it? As AI keeps crushing these complex benchmarks, what are the truly meaningful problems out there, the ones that would drive real progress for society, for the economy? And how can we design our evaluations, our research goals, to push AI development in those directions? Lots to ponder there. Thanks, this was a really insightful deep dive.
My pleasure. These are absolutely the critical conversations we need to be having about where AI goes next.